So we're going to start here with design for manufacturing and assembly, managing management time, project management, quality function deployment, the 10-step business plan, and lean manufacturing. The first one is one of my passions, and unfortunately, I've got to stay on schedule, but I'd love to talk about this for the full 90 minutes, but we can't because I've devoted so many years to this, as you'll probably see in just some of the few slides I've selected. Now, the first one is some of my favorite diagrams, which are Escher's with the big not sign in it. I like to use this one because, believe it or not, a CAD system does not know that these are not real objects. And I like to emphasize to people over and over again on design for manufacturing assembly. Just because you're using computer software in a CAD system doesn't mean you're designing or inventing something that's manufacturable. Because believe it or not, a mechanical CAD system thinks there's absolutely nothing wrong with this diagram. And that's one reason why I like to use it. And I'm always looking for applicable Eschers in our field of interest to put into a mechanical CAD system and to see if it can detect that this is an optical illusion and not a real three-dimensional or mechanical part. But design for manufacturing and assembly, for me, has been managing these barriers. The old paradigm over the wall is still, unfortunately, the way people address from concept to design to manufacturing, assembly, and even field service. And we would love to have these feedback loops. The only feedback loop that seems to be really, really efficient is the warranty, where you have dealers and distributors, and if something goes wrong under warranty, that certainly gets all the way back. But other feedback loops are sorely lacking. And one of the things I've worked on over and over is to try to capture manufacturing and assembly wisdom and bring it back to make it available for the design engineers, people like that. So the design for manufacturing assembly strategy I'm going to talk about, you might not be familiar with because everybody uses DFM, DFX, and they're all wrong. What they're talking about is design rule checking, finding mistakes. And what I'm going to show you today is the original definition of DFMA by the inventors of it, Professors Dewhurst and Boothroyd. And so I still prefer the purest definition of DFMA, but I've lost the battle to the design rule checking folks. And so one of my 25 skills is predictive engineering. So I had to give up DFMA because nobody understands it the way I'm going to define it right here. And instead I used the concept of predictive engineering. And that's because one thing about DFMA strategy is it gives designers and manufacturing engineers a common language, which are the design for manufacturing metrics. So if you've never heard of design for manufacturing metrics, because they don't exist in design rule checking, those are just design rules, then you begin to understand that the DFM metrics are really a means to an end to discuss alternative changes, improvements to reach a quality, cost competitive product. Because one of the basic tenets of DFMA is that manufacturing costs are driven by design. Design people, design process control 80% of the cost of a product to 85%. Only 15% of the cost of a product is controlled by manufacturing itself. This is a really difficult concept to get over to designers because they like to get it designed, prototype it, and then throw it over the wall and say, now it's your problem. And in manufacturing, we had to fight with it and say, but this isn't manufacturable. Well, and you can see here in a diagram, major drivers and significant impact of how elements of design influence the manufacturing cost in terms of vendors, parts, because it's all on the design drawings. They select the materials, everything else.